Quick show of hands, who here works with Kubernetes? Okay, quite a few, that's good. Have any of you ever in your Kubernetes cluster all of a sudden found a bunch of pods that were cryptocurrency mining? Okay, well, that's going to be the topic of today's talk. For those of you who aren't familiar with Kubernetes, we'll do a quick overview of what Kubernetes is. And then I'll talk about some previous research that we did looking at misconfigured Kubernetes components and those being exposed to the internet. Then we'll talk a little bit about a honeypot that we set up to catch attacks targeting Kubernetes clusters, and then how we expanded that research to see the larger scale impact of that. Now, if you've ever been to a Kubernetes presentation, you'll notice that they generally are nautical themed. That's because Kubernetes is Greek for helmsman. So this gave me the perfect opportunity to make pirate theme. But along those lines, we just need to clear up a few terms and definitions. So this here is Cryptobooty. Cryptobooty is cryptocurrency obtained from illicit coin mining in a Kubernetes cluster. So I'm kind of hoping that we can make this term a household phrase after this. Quick little bit on myself. I'm Director of Research at Lacework. Lacework is a startup out of Mountain View, California. We do cloud security, so everything from configuration and compliance for your major cloud providers to Linux workload security, Kubernetes, and container security. I actually got my start in the Air Force. Following that, I went to Mandiant, did incident response for a bit. And then I was at another startup called ProtectWise doing threat research. So my background is primarily in network forensics, incident response, threat intelligence, and cloud security. If you're interested in any cloud security topics, be sure to follow me on Twitter at Lacework Labs. And you can also check out our blog for any of the research that we do. Okay, so Kubernetes is a container orchestrator. It's an open source project. It's been open source for a little over 5 years now. Before that, it was developed at Google. And if you aren't in DevOps, you might be wondering, why do we need an orchestrator? Well, the main reason really boils down to, as you start to scale the containers that you have, and you start scaling the microservices that you're using, a lot of the smaller challenges on a small scale start becoming big challenges. And that's where an orchestrator can come in and help. So things like networking, such as if your container dies and you get a new IP address, how you're going to handle that networking easily, how you're going to handle service discovery, setting up strategies for deployments of how your infrastructure may scale up or scale down based on the load that you have. That's what your orchestrator does. Now, there's a lot of different orchestrators out there. Kubernetes isn't the only one. But right now, it's really become kind of the de facto standard and the most popular. So that's why we're talking about it today. Additionally, it has a number of security features. With each new release, it becomes more and more mature. So it becomes something interesting for us to study. Now, if you haven't seen this YouTube video before, I highly recommend checking it out. It's the Illustrated Children's Guide to Kubernetes. And essentially, it's a 10-minute video explaining how Kubernetes works from the point and story of a children's book. So this is a very simplified architecture for Kubernetes. Kubernetes is pretty complex, but we have some major components, and I'll just run through these real quick so future in the talk, this will make some sense. So all the servers in your Kubernetes cluster are going to be referred to as nodes. One of the most important objects is a pod, and the pod is what actually holds your containers. So an easy way to remember what pod is it's a pod of whales, and if you think of containers like Docker, Docker uses the whale mascot, and that's where the pod comes from. Also on the nodes, we have a daemon called kubelet, and that helps bridge the resources from the node to the rest of the cluster. Also helps keep the pods, check on the pod's health. Now, then we have special nodes called master nodes. You may have one or more depending on the size of your cluster. But they have what we call the control plane, and these are the critical components to keep your cluster running. That's your API server, which is essentially the hub of all the communications going on in your cluster. etcd, that's a database that's going to store all of your configuration and state. And then you have a scheduler and control manager to help schedule the pods that you're running and also make sure that they're healthy. Outside of the cluster, users can interface with it with a command line utility called kubectl, or you can also enable a dashboard to have a web front end to this. But at the end of the day, kind of the easiest way to think of Kubernetes is it's essentially a declarative API where you declare what your ideal state of the world is for your containerized applications. And then Kubernetes consistently is checking that to make sure that the actual state of the world matches what your declared state is. So since Kubernetes is a really interesting piece of technology and there's a lot of moving parts, it brings up a lot of concerns around security. So that's one of the motivations that took us down the path of let's kind of figure out what the security concerns might be with Kubernetes. And there's kind of two different roads you can go down. So one of the most common things that we see in the cloud is misconfigurations. This happens a lot with, a MongoDB is exposed to the internet, has a bunch of sensitive information, people find it, leak it out. The other side of the coin is probably some more of the advanced stuff. So this is, you have an application in a container, and that application gets exploited. What can the attacker do next? Can they move laterally within the cluster? Can they pivot into your cloud service provider account? Can they break out the container? What if your nodes get attacked? So we decided to focus more on the misconfigurations part of the puzzle because we wanted to really see what the scope of it is. Sometimes these misconfigurations seem really silly, but with the vast amount of different tools there are to bootstrap a cluster, it's kind of, you can kind of see how these might come along. So specifically, some of the major things that we see misconfigured are the dashboard. So you don't need to use the dashboard. This is a component that you can enable on your own. And what ends up happening is if this gets exposed to unauthorized access, depending on the account that the dashboard is using, there might be a lot that someone could do. So in like 2017, 2018, there was a number of reports of major companies where security researchers found exposed dashboards, discovered that there was crypto mining going on and that there was access beyond those clusters that can be gained. The API server is really interesting. There's actually two different parts to the API server. So the API server is in charge of authentication, authorization, and admissions control within your cluster. Now, it serves on two different ports. Most of your configuration tools are going to take care of this on its own, but one is referred to as the secure port. That secure port is going to be TLS encrypted and go through all those regular modules that I just said. Now, there's also an insecure version that just uses HTTP, and this bypasses authentication and authorization. So if this happens to get exposed to unauthorized access, whoever's hitting that can just make any sort of API calls that they want. And that's where we end up focusing some of this research a little bit later. etcd is the key value store. It stores your configuration and state, but something really important to note is out of the box, etcd isn't going to require any sort of authentication. It's also it's not going to have any encryption at rest. So the secrets that get stored in etcd are going to be base 64 encoded by default. And if you were to be able to access this, you'll get some sort of sensitive information. Generally, in a Kubernetes cluster, we can expect that at some point there might be credentials that are leading to the cloud service provider that's being used on. And then there's kubelet. Kubelet is the daemon that's running on all the different nodes. In some of the older versions of Kubernetes, there's a lot of issues with unauthorized access to this, such as scheduling pods and things like that. We didn't focus too much research on this. This one was a little bit more difficult to do some internet scanning on to go out and discover. But I'll give you a quick demo of how we can find open dashboards. So we use a variety of different tools. We use Census and Shodan, just mass internet scanning tools that can index the metadata that we're looking for. So specifically, if we want to find a dashboard, we just need some way to fingerprint it. We know it's HTML, so there's an HTML element that's pretty unique to it, and it's just Kubernetes dashboard. And so here, this is just doing a quick search in Census. We see about 500 different results. This is just a listing of IPs where there was some sort of result related to this. We drill into one of these, just one of the ones that we pick off the top, get some more info on it, and then we can actually go straight to the site. And within this, we found this completely open Kubernetes dashboard. In this case, this one, you could do whatever you want with it. You could see what's in etcd, you could schedule your own pods, things like that. The vast majority of the ones that we did find, though, did have some sort of authentication where you would be asked to give a token or a kubeconfig file. Some of the older versions of Kubernetes, the service account that's used on that dashboard is too permissive. So that's just one way that we can show you how we discover some of these things. So what we'll actually do is automate it in the back end, validate the findings, and go through that way. So just a few numbers of what we saw. This was earlier this year. Over 500 different dashboards that were open. 2,400 different etcd clusters. Now, the note on this is these etcd clusters, you can do etcd outside of Kubernetes, but a lot of these we found metadata that strongly associate it with Kubernetes. And so with these ones that are completely open to the internet that Shodan can pick up on, you can do a simple curl command and dump out all the key value pairs that are in there. On the API server side, we'd see between anywhere between 21,000 and 24,000 accessible API servers at any given time. Now, this is on the secure port. This isn't a huge security concern. You can do data leak. There's also a big CVE that came out last year related to the API server. But probably our most interesting finding was 600 different API servers with the insecure. So that means that these API servers are completely open to the world. There's no authentication or authorization involved in them. And anyone that is aware of those could essentially make the API calls they want with unfettered access. So kind of the next step is we did some research, see some exposure. You don't hear a lot about attacks that are targeting Kubernetes in the news, so we wanted to learn a little bit more about it. Specifically, we wanted to know if attacks are occurring, how long does it take to get attacked? We know that we can put certain applications up in the cloud, and within a day, we'll see multiple exploits being thrown at it. But what would it be like for Kubernetes? What happens if I leave my insecure API server open or a dashboard open? So I went poking around for just some more reporting. At the end of 2018, I started hearing a couple rumors about a few different things going on. This was a blog post entitled An Overview of MicroK8, a tool to quick start a Kubernetes cluster and why using it in the cloud was a terrible idea. And so that can kind of tell you what happened here. But essentially, they used MicroK8s, and I'll explain what that is here in a couple minutes if you're not familiar with it. But they put MicroK8s in a major cloud provider. They exposed it to the internet. And shortly later, they found that there was a bunch of cryptocurrency mining going on. Now, the interesting thing here is this kind of, it brought up a lot of debate from this thread, and a lot of people very familiar with the MicroK8s project were like, okay, you're not supposed to use MicroK8s like this. This is not the intended usage. And what it ended up doing is eventually there was a PR, there was a pull request in the MicroK8s project to bind that insecure port to localhost. So it made a decent splash. After that, later in December, we see, this was just this random comment I found in this forum that was talking about some different cryptojacking campaigns going on. And essentially they said they had a fresh MicroK8s installation. We see some different files being downloaded and executed, an interesting cron job. But the big thing to point out here is the conclusion is do not install MicroK8s with its default configuration on a server exposed to the internet. So that really gives us a great kind of starting point for our own experiment. So micro K8s, there's a lot of different tools for bootstrapping Kubernetes clusters. Micro K8s is quite a bit different because it's just a small, lightweight, single node K8s cluster. It's maintained by the same people that maintain Ubuntu. It's super easy to set up. You can set it up and have it running within a couple of minutes. But it's primarily used for offline development, prototype testing, things like that. It's not really meant to, do something large, production grade, in the cloud. So for our honeypot, all we needed to do was set up an Ubuntu server. We install micro K8s. It comes as a snap package. From there, you can enable various different add-ons. So we made sure to enable the dashboard so we could expose that. We made sure that the insecure API was accessible to the world. We exposed all traffic to that instance, ran TCP dump, put our Lacework agent on it, and then decided to go from there. And just as a disclaimer, as what I was saying, this is not how micro K8s was designed to be used, so this isn't a security flaw with them. This is simply just us using it as an easy way to set up a honeypot. So when I first set it up, I was really excited because I figured within a couple of hours or maybe a day, I'd start seeing the activity that I was looking for. But all that was really happening at first was a lot of different IPs were just scanning it, mainly hitting that API server that was open. And I'd see a bunch of weird stuff like directory traversal attempts and random exploits being thrown at it. But not much was going on there. There wasn't much traffic to the dashboard either. But after 31 days, we finally had success. So this is just a Wireshark screenshot, and what's going on here is this is just the typical scanning we would see on a day-to-day basis. And one of the things that was kind of interesting is even like for the majority of inbound HTTP requests that we would get, we'd always kind of get the same response from the API server, which was listing out all the different API endpoints. And then one day on day 31, we find this interesting user agent, and it's kube control. So if you remember from earlier, kube control is our command line utility that we can use to interface with the cluster. And this time they went through and looked at every single API endpoint. And then eventually what we end up with is we see a post request. Now what this post request is doing is it is creating a replication controller, so with 5 replicas. So essentially what that is it's a Kubernetes object where you can run multiple replicas of a given pod. And if we take a closer look at one of the pod configurations, we see that they're using CentOS as the image, and then we have the command that's used to run the container is a curl command for xmrig, which is an open source Monero miner. And then it pulls down a configuration file and then changes, makes xmrig an executable, and then go ahead and executes it. So the thing that was really interesting to me at this point is I kind of just assumed that an attacker would pull down an attacker-controlled image that was already set up and then just run it that way. But this was a better way for them to do it because it's just a clean CentOS image. It's not something they have to worry about people finding on any major repos. Another interesting thing is we see this container name, myresdo2. So that comes in handy here in a little bit. This is just a configuration file for xmrig. We have this Monero address that we can do a little more research on. We see custom mining pools. And then what we saw is the IP address that was used to pull down xmrig and the configuration file was actually in a lot of other previous research from different security vendors and private forums and things like that. We see a lot of ties to the 8220 gang. And then we see that Monero address used in other cryptojacking attacks. So the big thing that we learn here is that this is just one part of many other types of cryptojacking attacks, whether it's Jenkins or Drupal, things like that. So we wanted to take this and kind of expand it. So we saw all this other misconfiguration going on? Is this happening to some of these other clusters out there? So we revisit our previous research, and we focus on the IP addresses that have that API insecure port open to the world, which is about 678 of them. So we take those IP addresses and we scan their pod configurations. And this will give us kind of a good idea if there's any indicators of compromise going on. We see about 10,700 different pods, and when we rack and stack some of the metadata attributes, immediately we see these pod names that you see listed up there. One of them was the same naming scheme that we saw in our honeypot, and then we see common labels and common container names of MyResD02 and MyResD01. And then CentOS being a popular image in the bunch. To dive a little bit deeper, we end up looking at what commands are actually being used for the containers. And we see what ends up happening is 5 different distinct curl commands. And these curl commands really follow that format of what I showed earlier in our honeypot. And these basically are curl down for a file. Sometimes it's named xmrig, sometimes it's named something else like this suppioie1. Download an additional file, which is our configuration file, and then go ahead and execute and run those. So sometimes this was just to hard-coded IP address over port 80, sometimes it was 8220. And then even in one instance that I found pretty interesting is they pulled xmrig directly from GitHub. So from this, we see, okay, like we have a lot of pods that are basically doing something really similar to what we saw in our honeypot. When we tallied it all up, out of that 10,000 I showed you before, 4,450 pods were being used for crypto mining. And then when we take a closer look at some of these IP addresses that were used to download any of the files, we see a lot of different overlaps. The first one, we see the one from our honeypot showing up a lot of different times. We see another one that was in some of those prior blog posts that we saw in Microcades. And then we also see one in some older reporting on Drupal get-in attacks and things like that, with a lot of ties coming back to the 8220 gang and some other various groups. So this ends up telling us that, anyone who has this insecure port open to the world is likely running a number of pods that are doing cryptojacking. And from within that, we know that these, the attackers behind this are actually involved in other different cryptojacking campaigns going on, probably some much bigger ones that you might read about and hear about. So something that really stuck out here to me is that, cryptojacking is really the tip of the iceberg. Now, when we're doing our research, we be careful to, not go too deep. But looking at some of these pod configurations, it's very clear that some of these clusters are running probably have secrets to like AWS accounts and things like that stored within etcd. And so if someone was going to be doing this manually, there's a lot more they could do. For example, if you got into someone's AWS account, then you could spin up whatever resources you wanted until the people owning that account eventually turn that off. So this is a list of resources. What I'll do is I'll share on our blog these slides, so you'll be able to take these slides, go through some of the different things that we've looked at. To find our blog, it's just lacework.com/blog. You can also email me anytime, follow on Twitter, all those things. And then with that, we're about out of time. So if you have any questions, just feel free to grab me afterwards. Thanks, everybody.